Welcome everyone to Knox Game Design for December 2022. So this month I'm going to be talking about QBasic, input, output, and graphics. So this is going to be a little bit more in depth. I did a presentation, I guess a few years ago, on just an overview of QBasic and the history of it, but this is going to be a little bit more in depth. So I learned programming back in around 1995 when I was a teenager using QBasic. And back then we didn't have internet access or anything. That's like right when Prodigy and AOL were starting to start up, and you were limited on how much time you could spend online. Is like $9.95 for the first like 5 hours, and then $2.95 for each additional hours. And there really wasn't a lot of stuff on the internet back then. So everything that the only reference I had to learn QBasic was through the built-in help files. So going back like 27 years later now, I can look up things I didn't know back then and really learn how some of these things work. So I made a few basic QBasic games back in the day, and I always like wanted to make a Final Fantasy game. But the problem was I never was able to like get that real-time keyboard feel, the input, really wasn't able to do the nice like graphics or anything. But going back now, I found out you can do some of those things. So the first thing that after I went back and looked at it, there's this thing called N keys. And this is basically how you get input from the keyboard. This is the way, if you look at the example programs, they tell you how to do it. Just to get the value from N keys. It's like a buffer of keys that the user has pressed. So every time you call N keys, then it gets the next button. So what I didn't understand back then was, well, if you get that value from N keys, like if you press the letter A, then it's going to return A or capital A, like it says here. If it's a standard key, then it just returns the value of that key. There are some exceptions, like the escape key is character 27. That's what that CHR dollar is. It's kind of like casting an int to a character right there. Tab character is character 9, number 9, and space is 32. That's kind of standard ASCII character values, or American Standard characters for information interchange. But what I didn't understand, one thing I never was able to get working in any of my old games when I was learning programming when I was a teenager, is how do you get the arrow keys? So all my games, I think I just use like ASDF or the numeric keypad, like 4 for left and 6 for right, 8 for up and 2 for down. But I found out there is a way to get the arrow keys. And I think I knew this because I mentioned it later in the slides, but there's 2 example programs that came with QBasic. And my first computer was a 386, DOS 5.0. I think I eventually upgraded to DOS 6.22, Windows 3.0, and upgraded to Windows 3.1. But back then, Windows was more like an application that ran on top of DOS, so I really didn't spend a lot of time actually in Windows. If you're playing games, it's a lot faster just to boot into DOS, directly into DOS. And then you could always run Windows. I think you just type Win, W-I-N, that would start up Windows. So Windows was really an application back then. But if you really wanted to play games, you really didn't go into Windows, Windows 3.0 or Windows 3.1. You just ran them directly from DOS. So the point being is like, well, whenever I was programming, I just run QBasic directly from DOS. There's two example programs. One was Nibbles and one was Gorilla. And it's basically like a standard snake game where you eat the apples, or I think it's numbers. And then as you eat more numbers, then your snake increases. But the point of that is that example program used the arrow keys. So I knew there had to be a way to get the arrow keys in QBasic. And these days with Unity and GameMaker, you don't even think about it. It's like, okay, they just provide functions to get any key that you want. But reading through some of the documentation, looking at some of the stuff online, I did find this. To get one of what they call the extended keys, the non-printable keys, then what it does in keys, it returns a 2-byte string. And back when I was learning programming, I didn't have any idea what a string was, a character string was. Really didn't know about concatenating and how to get a byte out of a string. I just knew it was just like a word, like hello or whatever world was a string. But I really didn't know that each character of that string was an individual byte. So what you can do is you can get the first byte and the second byte of your int key. So if it uses an extended key, then it's going to return a 2-byte string. The first byte is going to be character 0 or int 0. And then the second number is, I think, typically the keyboard scan code. So whenever you press a button on your keyboard, that is associated with an integer value, which I'll show here in a second. So to get the left arrow, basically, you're going to get a 2-byte string from int keys. The first is going to be 0, and the second is going to be 75, which is the scan code for the left arrow. If you want to get a function key, then the first byte will be character 0, and the second one will be 59. So this works. So I was kind of happy I was actually able to get a demo working. I think I have my DOS box here up and running, QBasic, and I already got my drive set up, so I got my programs on drive. So this is key demo right here that I wrote a few days ago. So I got these keys defined here, like escape, key 1, A upper, A lower. The nice thing about int keys, it can detect whether you've pressed an uppercase A or lowercase a. So you don't have to actually check the state of the shift button, which is kind of nice. But here's what they call the extended characters. So I got these two characters. So a character is basically an integer, an 8-bit value, and two of those together makes 2 bytes, 16 bits together. So we're just concatenating these two together right here. So I got this thing called key last, the last key that the users press. So if the last key the users press is empty, then we're going to read out of the, let's see here. If it's not empty, then we're going to take the key that's pressed and assign that to key last. And there's a reason for doing that with the key buffer. But here I just do a check. If the key pressed is character 65, which I could have just used the key A upper up here, then it'll say you pressed A. If it equals character 97, then it's going to press you pressed lowercase a. And what's interesting is it starts out on, I think it's bit 6. So A is 1 and 5 zeros followed by a 1, I believe. So the first is an at sign. So it starts with at, then it goes to capital A, capital B, capital C, all the way to capital Z. And then I think there's a few additional characters like question mark. Actually, you can go into the help. So this is what I used when I was a kid. You had to press F6 to go between these. And you go to contents. And yeah, here's your ASCII character codes right here. So this is what I used when I was a kid, trying to figure all this out. So like I was saying, 64, yeah, it starts out with an at sign, so it goes A through Z. So then you got a left square bracket, a backslash, a right square bracket, a caret, an underscore. The 96 is a grave sign. I believe that's what that is, backward tick. Then 97 starts with lowercase a, then goes to lowercase z at 122, and it just goes up to 127. So that's the standard codes. Then you got the extended codes, and this is all the cool ANSI graphics that you can do that you've seen, that I've talked about and used in some of the BBS games and things like that. So yeah, basically go through all these characters and just say, hey, if it's character 0 plus 75, then you press the left arrow. So it's really not that intuitive. So when I was doing this, I found another way, which I'll talk about in a minute. You can't get the control keys. You can't get like the toggle keys. And you can't get you can't do a character 0 and get one of the standard keys, which is kind of unfortunate. It would be nice if you could. F6, F6. So it's like S is 83 or 115. So you can't just like, I don't know why I had 31 there. Oh yeah, you can't get the keyboard scan code. So that's the scan code for an S. So I'll talk about scan codes in a little bit. But you can't use the extended key method for the standard keys, which a little bit, I don't know. It works, but I wish I found it like a standard way using the scan codes that applies in any situation. This method is like a little bit inconsistent because you got to know what is a standard key and what is an extended key. So here I was just kind of playing around getting the bytes, so you can use like the mid-dollar. This is kind of like a substring right here. Get the character at 1 byte, then get the character at 2, 1 byte, and remember that in QBasic all the indexes start at 1. I've ran into problems when I'm like using a locate statement. Locate basically tells where you want to print. Like right here, locate 1. That's where you want to print on screen. If you do locate 0, then your program will crash. And I'll be scratching my head. I'm like, well, what did I do wrong? And I was like, oh yeah, QBasic starts at 1, index 1. There are some additional functions which I mentioned later. You really don't need to worry about these. I'm really not going to talk about peek and poke and sad with a double D in here. It's just a way to get the memory location of a string. So I'm going to sleep, and then I'm going to read the key press from the end keys. And something I'll talk about here in a minute is clearing the input buffer. So basically just going to loop until key press equals this key escape. And the key escape is character 27. So if you run this, so I got the end key value, so I'm just going to like press D. So I press D. If I hold shift and press D, then it's going to display my capital D. If I press F1, then here's where I'm going to go in. So I'm showing the byte. The first byte is 0 and the second byte is 59, which is the keyboard scan code. But if you just print these out, it's just going to look like a space and a semicolon, because 59 is the ASCII character for semicolon. But using the extended method, it's really getting the keyboard scan code. So if I press Q, it's going to do 113, capital Q 81. So now we're working with the ASCII value. So if I press the number 1, 49. If I do exclamation point, 33. 2 is 50. 3 is 51. 4 is 52. Like I said, if you do lowercase a, then that's 65. S is 83. D is 68. I guess I got my caps lock on there, maybe. Capital F is 70. If I press up arrow, it's going to give me 2 bytes. So the first byte is going to be that null character, which is 0. The second byte is 72, which is the keyboard scan code. But when you actually print that out with the print statement, it's just going to look like a space or an empty followed by a capital H. So in some of the examples, like in the nibbles example, you'll actually see the program say like character 0 plus H, which makes it even more confusing. I like just working with keyboard scan codes. It's just kind of standard. So left is 0.75, right is 0.77, down is 0.80, up is 0.72. And those are int values. Those are the character int values right there. If you do insert, so here's another extended key. It's 0.82. Delete is 0.83. Home is 0.71. End is 0.79. Page up is 0.73 and page down is 0.81. Usually don't use those in a lot of games, but the arrow keys are important. I think you can do scroll lock. No, you can't do scroll lock with end keys. So press escape. That gets us out of that. So that's kind of like the basic input method. And the 15-year-old me would have been never really understood like the concept of like the 2-byte string here and like getting the arrow keys out of that. So that's I kind of want to go back and remake my games when I was a teenager using some of these things that I learned. Yeah, here I mentioned unable to get toggle keys like control and scroll lock. So I actually do put the ASCII reference here from QBasic.net for the ASCII key and scan codes. But remember, if you just press F1, actually you got to press F1 on a function there. You can go to press F6 twice. You can go to the contents. And the keyboard scan codes that I mentioned, just press enter there. So you can see, well, does this have the arrow keys? Yeah, so left are 4 is 75, right are 6 is 77. So the thing is with the keys, the scan code method, you can also get the numeric keypad. So it doesn't really make any distinction between the left arrow key and the number 4 key on the numeric keypad. And also you got to make sure that I think the number lock is on, otherwise it won't register. So that's where you get the keyboard scan codes right there, or you can find these online too. So just remember, within keys, there's 2 different methods depending on. And oh, by the way, Control F10 breaks you out of DOSBox's window here. That's something took me a little while to figure out. So right here, I just took screenshots just in case somebody needed an additional like online reference or something. I got it right there. So the keyboard buffer, whenever you're banging on the keyboard, that feeds this buffer. And I read a little bit about the details. I think it's like actually stored on the motherboard, so it isn't in memory or anything, but it reads from this input buffer, and it's like first in, first out. But the problem is, if you're holding the button down, it's going to, every like frame, every update, every time you read in keys, you're going to read 1 character off that. And that's something you probably don't want to do. Like if you're making like an action game, you just want to detect when the key goes down and when the key goes up. Because whenever the way this keyboard buffer works, when you hold the button down, it registers once, like dut, and then it waits like a second, and then it does this auto fire. So it's like dut, 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 dut. So that's the way that it registers the key. So if you're holding down like the A key, you're going to get A, and then A a bunch of times, like a few seconds later. So what I do, and I think there's an example of this in the example programs, you can clear the keyboard buffer. And I saw, if you go into your favorite search engine and look up how to clear the keyboard buffer in online, then you'll get a lot of like articles with people asking how to do it, not a lot of good solutions. But this is a great way to do it. You just say while in keys does not equal space, because if in keys equals, if it equals the blank string, then it means there's no more keys in the key buffer. So you just say while in key, so that's going to keep reading, looping until that key buffer, that in key is empty. So that's what I have down here. While in key does not equal that. If I didn't have this in here and I held like the A button down, the A key down, then I'd get an A. And then if I pressed another key, if I held down A for a couple of seconds and then pressed a different key, then I'd get another A and another A and another A and another A. Then like eventually the next key that I press. So it's good to clear that key buffer out if you're doing a program like this. Okay, so this is a new method that I learned. So I call this keyboard advanced or simplified. So you can use this QBasic function, which I never really knew about when I was a kid. It is in the docs, in the help manual, but I really never did understand. I didn't even know what hexadecimal was when I was a kid, but you can see some examples of hexadecimal here. But IMP reads a byte from the hardware port, which I'm still really not clear about. I just know that this keyboard buffer hardware port is at location decimal 96, which is also hex 60. If you do the conversion, I did talk about converting between decimal and hexadecimal last month. So if you want to know all about converting between number systems, look at November 2022 Knox Game Design. So you can either specify INP 96 or INP, and how you specify a hexadecimal number in QBasic is with ampersand capital H, then the number. So ampersand capital H 60 equals 96. So you can either do IMP 96 or IMP ampersand H60. So in this example, just going to print that out. So if the character equals, and in QBasic, you just only use I know it looks like assignment. It's really hard to get back into only using a single equal for test inequality, but that's how you do it in QBasic. So if equals like 30, then it says you pressed A. Then we're going to sleep, and then while we're not pressing a key, then while we haven't pressed the escape key, which is 1, scan code 1, then we're going to loop. But whenever the keyboard scan code equals 1, then it's going to stop looping. So yeah, with this method, so if I didn't mention before, this uses the scan codes for all the keys. There's none of this standard keys and this is all the keys on the keyboard, the 101 standard keyboard. You can get almost all the keys. I found out print, screen, and pause don't work, but any of the other keys, and also the Windows and menu key, which back then in DOS they didn't even have Windows and menu keys. And as I mentioned before, the arrow keys share the numeric keypad values as well. And the nice thing about this is you can actually detect when the key is up. So if it returns like a scan code greater, I believe, than 128, I could be wrong about that. But I think all the standard keys are blue, which I have a diagram I made next. I think there's actually a bit. It's like the bit 6th or 7th bit tells you whether the key is up or down. So I'm going to have to press space here. So I found a blank keyboard layout. So I just put in the numbers right here. So these are not the ASCII values. These are not Unicode values. These are keyboard scan codes, which I think are pretty standard between all keyboards. So like here you got A is 30, so it kind of starts out 30 and going from left to right, ASDF 30, 31, 32, 33. Like QWERTY is 16, 17, 18, 19, 20. F1 to F4 is 59, 60, 61, 62. Your arrow keys, like I mentioned earlier, left arrow is 75, down key is 80, right key is 77, and up key is 72. But yeah, just be aware that it shares those same keys with the numeric keypad. But with the numeric keypad, you also have like 76 for a 5. It kind of goes in rows. 7, 8, 9 is 71, 72, 73. Then minus is 74. 4, 5, and 6 is 75, 6, 77. Then plus is 78. You can also get the Alt keys and Control keys. It doesn't make any distinction between the left Control or Alt key and the right Control or Alt key, but it does make a distinction between the left shift and the right shift. Not sure why, but I guess that's just the way they designed the keyboard. I guess they originally just started with one Control and one Alt, and they had I don't know. But yeah, just know that you can get the left shift and the right shift. Enter is 28, backspace is 14, escape is 1. So those are almost all the scan codes right there. So let's go back, Alt file open. So this is using the key port. We don't want to save that. So this is basically what I just had right there. So go ahead and start this. So it just detects if you press A. So by default, it's just going to put 170. So if I press A, it's going to say you pressed A. The one downside is it doesn't make any distinction between capital A and lowercase a. So you're going to get a 30 whether the shift is held or not. But the nice thing is, so I'm going to do ASDF. So 30, 31, 32, 33. But you can see as I lift each key, I get 158, 159, 160, 161. So you can actually detect using this method when a key is lifted up, which is kind of nice. If you're doing a real-time game, you need to know when the key is up, because usually when you're moving a character around, you want to start accelerating the character on key down, then stop the acceleration when key is up. So the other in-key method, you can't detect when the key is up. You have to use this INP method. And by the way, if you go into the help menu, then you can read all about INP, read a byte from hardware, and there's also out where you can write to hardware. Like if you're writing to a serial port, like a serial modem or a parallel port, things like that. Maybe one of those you can actually write back out to. I can't remember if it's a serial or, I guess, parallel port you can't write to, something like that. So that was like how to solve my problem, my teenager problem of of how to get the keys and detect when the key is down, when the key is up. Because in my old QBasic games, it would have that problem of the character moving one, then gradually across the screen. So it just really didn't feel right. So the other problem that I had was drawing to the screen, which I did have it where I didn't know enough where I could create a standard like draw string, which would like draw one of these trees, but I'd be calling draw over and over and over again for every one of these trees here. Which is okay, but it kind of has that pop-in feel. So I have these broken into different cases. So the first case is drawing. For each object, the objects fill in as they're drawn, which is kind of cool. If you're going for an old school feel to your game, you can actually see the paint algorithm filling things in, which is kind of cool sometimes. But I put here slow. It does have the old school feel. And it may be okay if you're not redrawing on every update. So yeah, it is a very slow method, and it will start to lag. Okay, so I'm just going to show some of these examples. The first one is just drawing the different lines to the screen, the different characters showing. Like in screen mode 13, there's different screen modes which you can look up in the help manual. You can go here, screen modes. So these are all pretty low resolution by today's standard. I usually work with screen 7 or screen 9 if I'm doing double buffering, which I'll talk about in a little bit. It has off-screen pages, so you can draw stuff to the off-screen first before you flip it over. But this one is screen 13, which is 300 by 200 graphics. So I guess screen 12 is 640 by 480, which was the first monitor I had. Was 640 by 480, but it only had one video memory page. So everything that you drew, you're drawing directly to the screen. There wasn't any ability to draw to an off-screen image. I think some people have found a way to hack that to get sort of like double buffering. But this is just like showing the different colors right there, looping through. So you start out with the standard, like 16, then you go through the shades of gray, then you go through all the different hues, and a lighter value, lighter saturation, and a lighter saturation. Then it goes to like a darker saturation after that. So this is a demo that I found online drawing lines. So this is drawing lines to the screen without any double buffering. So you can see let the lines draw as they come in, which is kind of like the old school way. So basically what this is doing is clearing the screen on every loop, kind of like every update. And then it's just drawing a random line at a random color. I shouldn't have that P copy in there. That's for the next one. So if you go to 2B, so I'm using screen 9. So what this 9001 means, that's saying 9. I think the second number is like whether it's color or monochrome. But the third and fourth line is whether the active screen and the double buffering screen. I think they call it like the drawing screen or something in the help manual. Screen modes. So screen 9. So if you want to do double buffering, it's got to have right here one video memory page or 2 pages. Trying to go back. Can I press F1 on the screen here? Yeah. So yeah, the color switch, that's the second number there. So this is the second method, and you got to call this pcopy method right there. So pcopy is going to take what you've drawn on the off-screen image, then put that as the active screen. So if we run this, you can see all the lines each time. So this is something I always kind of wanted to do when I was a kid. It's like, yeah, just have one frame per update. So you don't get the cool paint filling algorithm stuff, but you do just get that single image at a time, which I don't know. Looking back, I think the paint method is actually seeing the paint method filling in is kind of cool because you really just don't see that anymore. Just gives it that old school feel. But if you want to have everything drawn at the screen once, you got to use screen 9 or screen 7, and then set the active and drawing screen, then do this P copy to copy everything over at once. So I kind of showed the example here, like if you're not doing double buffering, you can actually see these trees filling in right there, which I think I had. Yeah, so it's still pretty quick, even though this is emulating in DOSBox, so this is kind of emulated the same speed as an old 386 or a 46. But if you look really quickly, you can see these trees are filling in. It draws the outline first, then it fills in the green top, and then the brown bottom trunk. So yeah, using screen 7. Here's like the drawing code for drawing the tree. This is pretty similar to what I had when I was a kid. So we're just going to call draw. And this var pointer dollar, that just says use the value with this SPR tree dollar. And then we're going to paint the green and the brown base. So then on every loop, we're going to fill in the background of green. And then we're going to go 9 columns across horizontally, then 5 columns down, and draw each of these trees. And basically this draw basically moves, this BM for draw moves the drawing position to the X and Y coordinates that I specify there in the loop. And then you do an X, and then you specify the string that holds the drawing code. And then we're going to fill in using paint the green top and the brown bottom. So that's what that's doing right there. Then we're just going to sleep and read keys until the key equals escape. So this is the old method that I was using. So yeah, I should replace this with the while. So this does the same thing as the while, clearing the key buffer, just a little bit extra. And that's the first way I figured out how to do it. Then I found that other while wind way, which is a little bit more efficient. That's the first method, drawing each individual. So the second case is what we're going to do is we're going to draw a reference image. So we're going to draw one tree, and then this is something I didn't know how to do when I was a kid, and I know how to do it now, is you draw the image of the tree using your standard align and paint, and then we're going to use the get command. So that's going to get the array of pixels at the location that you specify. So we're going to do like 0 to 31 to get 32 by 32 pixels. So we're going to have that sprite in memory. And then every time we want to draw a tree, we're just going to use the put command, which puts those bytes into wherever we tell it to. We put it in the video memory. So we're going to just kind of like stamp. It's kind of like stamping that tree at each location. So now we're not going to see the paint filling effects. It's actually going to fill line by line. So you're kind of just going to see one tree at a time. So yeah, it's faster than doing the draw and paints for each individual tree. So if we go here, file open, GFDemo3. So yeah, we do this dim. Dim means dimension, kind of like defining the variables. So we're going to image tree. It's going to be 32 by 32 pixels. We got the same draw statement right here for sprite tree. We're going to draw like a solid green rectangle for the background. Then we're going to move the cursor to 0, 0. Then we're going to draw that tree. We're going to fill it in. Then we're going to do get to get the pixels where that tree is drawn. That's kind of like silly putty, where you put the putty on the image that you want, and then once you got it, then you go, I guess you can stamp it on other places, kind of like what we're doing. So we're kind of like creating the stamp. And then down here, we're going to use put, then XY, the coordinate, based on the row and column. And then we're just going to reference that image tree and then use pset. So there's different options you can use when you're stamping these trees. I think one's like XOR. And it basically tells how the image, the bytes that the pixels that you're stamping in, how it's going to interact with the existing background. So let's run this. So there's our reference image. We drawed it, then we got it into memory, and then it draws it. So if you got a really good eye, you can see this is a little bit faster than the previous method, and you don't have any filling effects. I think there is a way in DOSBox to slow down the cycle speed, but I really don't want to mess anything up right now. But if anybody wants to, you can get this code and slow it down if you want to. So that's a pretty good method right there. A little bit more efficient than drawing each individual tree. But the third one, I think this is the best case, is the double buffering. Like I said earlier, screen 7 to 9 allow buffering drawn to the off-screen images, not with VGA modes, which is unfortunate. And like I mentioned earlier, you can use pcopy to copy the draw screen to the active screen. You don't have any pop-in. But this is still, in my opinion, too slow for a real-time game. You're getting like 1 frame a second. So it might work for a strategy game, things like that. And I think on the next slide I mentioned blitting. Let's see here. So GIF demo 3. So this is kind of the same code right here. Okay, so this is the exact same code. The only difference is we're doing pcopy 0, 1. So we're drawn to the off-screen image and then copying it over. So if we go back to 3B, we don't want to save. We just got screen 7 here. If we go to 3C, then we got screen 7, 0, 0, 1. That's the only difference is we're defining the off-screen image buffer, and then we're calling pcopy after we're done drawing. So press Shift F5 to run it. So there's our reference image, and there it is right there. I'm pressing space. So there's no filling effects at all. I should have went in had something moving around, but it's really slow. It's like 1 frame a second. And the reason why I clear the key buffer there is if you keep pressing buttons, then it'll take a while to actually register your escape key. So it's good to clear the key buffer after every update. Yeah, so that's basically it. I was going to mention blitting. I didn't actually implement this in any of the demos, but so if we draw the trees, which takes a little while, and we got a person on the screen. I actually did this in my old games when I was a teenager. Instead of redrawing the whole screen again, you just want to move your character and redraw what was in the old position. Draw the character in the new position, then redraw what was in the old position. That way you're not redrawing the whole screen. So that works pretty well. Speeds up drawing time, reduces the lag, works good for not real-time games. Or if you're not redrawing the entire screen every time, just redraw where the character moves. So that works pretty good. I'll also mention there are memory manipulation functions. I didn't get into it, but I think there are maybe even faster ways to draw through the screen, just writing directly to the video memory, which I didn't get into that. I'll mention it here. So here's some of the advanced, I guess I did kind of mention it here, more advanced memory manipulation. So this is if you're an assembly programmer, this would probably make more sense, if you're actually going in, getting the memory addresses and flipping bits and things like that. So varseg and varpointer, mentioned a little bit about that, getting the memory address of a string. I've seen defseg quite a bit to access a memory position and memory. Let's see peek and poke quite a bit for reading a value out of memory and poke is, I guess, maybe a faster way of changing that video or a memory location right there. Then there's SAD, which I think is SAD used to be Students Against Drunk Driving. There's MAD and SAD, Mothers Against Drunk Driving, Students Against Drunk Driving. But SAD is get memory address of a string. Then there's wait, or if you need to wait, it can possibly freeze your program. And then you got, as I mentioned earlier, INP and out. So what I did is I made an improved shooter game using kind of the stuff that I learned about game development over the years. So now I did a demo of this a few years ago on the Knox Game Design talk, but it's flickery. It didn't have arrow keys, so I went back and made it a better shooter, and also have like a function. They call them subs, procedure for drawing the screen, updating the screen, and a knit, and then I have one for specifically for shooting and one for checking collision. So one thing I will mention is don't name your sub function, sub procedure draw. It will not be happy because there's actually a draw is a reserved word. It's one of the commands, so don't try to name your sub function draw. So I called it draw screen. So let's go here, open. We want to open QB shoot. So here it is right here. So I'm using screen 7, got a randomized timer going on, randomize. I got a player defined. So in QBasic, you got types instead of classes or structures. So you got type, I got a type player, and I got a type bullet and a type enemy. So I just have one player, one enemy, and you can shoot one bullet at a time. I didn't want to get into arrays because arrays will slow things down. I don't even know if it's possible. I know it's possible, but it'd probably be really, really slow the more enemies you add and more bullets you add. So I got a defined P as player, E as enemy, B as bullet, and then I got a C for the character input. So I will mention the player, the bullet, and the enemy all have an XY, width and a height, W and H. They all have a vel X and vel Y, although bullet only uses vel Y because we're shooting upward. And for the bullet and enemy, I have an is alive value, which tracks whether the bullet is alive or the enemy is alive. So we can turn that on or off, make them active. Also for enemy, I have a speed, so I can vary the speed of the enemy. So as you defeat more enemies, they get faster and faster. And then I got a respawn delay, so if you shoot the enemy, it's going to wait about a second or so, and then respawn that enemy so you can shoot him again. And every time he comes back, he'll be at a random position. I got a bounds value here for saying, hey, the player can't go above a certain Y location. Got a score. Every time I shoot an enemy, I think it gives you 100 points. Got a time limit that ticks down. Otherwise, it wouldn't be a game. You just keep shooting enemies forever. So the time limit kind of makes it so you can see how many enemies you can shoot within that time limit. And then I got is game over. So once the time limit reaches 0, then we're going to say game over. So here I'm getting a character using that IMP ampersand H60 using the keyboard scan code. So then in my loop here, I just have a knit before the loop. Then I have do and a loop while C does not equal escape. And within that loop, we're just going to get the character. And then we're going to call update and draw string. So update. So I got all the key codes here. So if the game isn't over, and oh, by the way, for the game over variable, I just use a 0 and 1. QBasic doesn't have a concept of a Boolean value. So I just use a 0 and 1 for that. So I got all the keys defined. So if they press the up key, then we're going to set the Y velocity to -4. If they press down, we're going to set the Y velocity to 4. If they press left, then we're going to set the X velocity to -4. If they press right, then we're going to set the X velocity to 4. And then if they press space, which is key code 57, then we're going to call shoot, P shoot. So the nice thing about this, if they release the left key and the velocity of X is less than 0, then we're going to set the X velocity to 0. So if they're going left and release left, then we're going to set the X velocity to 0. This should really be acceleration, but hey, this is QBasic. So we're just going to do velocity. It's kind of, you don't have that speed up and slow down effect or anything. If they're pressing right and they let go of right and they're moving to the right, then we're going to set the X velocity to 0. Same for up and down. If they're going up and they release up, then we're going to set the Y velocity to 0. If they're going down and they release the down key, then we're going to set the Y velocity to 0. Otherwise, you just press down or whatever key, and they'll keep going in that direction forever. So updating players is easy. You just add the X velocity to the X position, add Y velocity to the Y position. Got some bounce checking here, like I mentioned earlier. Just make sure if the player goes above the allowed line, then we're going to stop them. Or if they go further left than 0, then we're going to set it back to 0. If they go greater than the screen width, we're going to set it back to screen width. That way they can't go off the screen. This is basically the enemy AI right here. So if the enemy is alive, then we're going to add the X and Y velocities. And if they hit the screen, left or right of the screen, then we're going to reverse the X velocity. So send them the other way, the enemy the other way. Then if the enemy is dead, if the enemy is not alive, and the respawn delay is greater than 0, then we're going to reduce the respawn delay. Then when it actually does get to 0, then we're going to set a new location for the enemy. Add on, speed them up a little bit, speed them up by 2, and then we're going to cap the speed at 20 so it just doesn't go completely bonkers if they get so high. And then we're going to set the X velocity to the speed, and we're going to set the enemy as alive. So that respawns the enemy after a brief timeout. Here's the bullet. If the bullet's alive, we're going to... I shouldn't even have the X right here because you can only shoot the bullet upward. If the bullet gets to the top of the screen, then we're going to set is alive to 0, so we're not updating the bullet if it's off screen. Then for each update, we're going to check the collision of the bullet with the enemy. So if I did have an array of enemies, and you would want to loop through each enemy in the array, but I think that would just slow down things so much. So I have that check collision sub procedure. So check collision. Go back. I did a whole talk on a few months ago on collision, 2D collision. So this is the code right here. If the bullet is alive and the enemy is alive, and if the X position of the bullet is to the left, to the right, above, or below the enemy, then it doesn't collide. Otherwise, it does collide. That's what that's doing right there. And so that's what that, if check collision equals 1, then we're going to set the enemy to dead, is alive to false, or to 0. We're going to set the bullet is alive to 0. We're going to set the respawn delay of the enemy to 60. That will vary based on how fast your game is running. I could go in here and add like a delta time type deal, but when you're dealing with ints, there is a long data type and a few like floating point operations we could use in here. But just for this simple demo, I didn't do it. And then play, that's how you play music. I used to love messing around with play because you can like set different octaves and length of notes and things like that. Using play, and on every loop we're going to decrease the time limit by 1, and then if the time limit equals 0, then we're going to set is game over to true to 1. Then on our draw, we're just going to locate 1 1. Still got the key scan code right here, printing that out just to show what key we've pressed. We've got the score we're printing out, the time limit, if the game is over, then we're going to just print in the middle game over. I got that commented out. So drawing the player. So right now we're just using boxes. You draw a box with the line command. So line will draw just a regular line if you specify this BF. I think that means block filled. It'll make a rectangle instead of a line. So the player is just a blue square. The enemy is a green square. And then the bullet, I think, is a red square. So you could go back and actually add graphics for those. And here we're just drawing the bounds where the player can't leave. Then we're using that P copy to make it double buffered. So after mentioning all that, here's the game. So yeah, we've got the character moving around here. You can't move above the Y bounds. Can't move to the left or out of bounds. So I forgot I added a sound for shooting. But you can see those keyboard scan codes up there at the top. And then when you let go of a key, it'll actually put the code for releasing the key. And like I said, I think there's actually a bit for up and down. It's actually kind of a challenging game because you can only shoot one at a time. So you kind of got to anticipate when your bullet's going to reach the enemy. So we're getting almost out of time. Got 500 points. Oh, game over. So I scored 500 points. You press the escape key to quit. So I think that's all the demos. On the last slide, I'll go ahead and mention, when in doubt, look at Nibbles, the snake game, and Gorillas. I think I mentioned this like on the previous QBasic talk that I did, but like Nibbles has a lot of good information. So I won't go through all this code, but they got everything pretty nicely defined into different procedures and things like that. And if you run it, it actually asks you if you want color or not. So yeah, I remember playing this. Like, you could actually go into the computer lab at school, and they'd have like IBM compatible computers with this on there, and you could play snakes and everything. So if you run into yourself, you crash. I think the only downside is you can't actually break out of this. You actually have to lose. But anyway, when the Gorillas was kind of the same. You can actually get negative points. I wish there was a way to stop this darn thing. Yeah, so here's the Gorilla, A, B. And it's like you had to have 2 players or play it by yourself. So you type in an angle, 45, velocity, 50. And you just throw bananas at each other, trying to hit each other. 30. Actually, I should do like 80, 70. Then you just try to guess what the required velocity and angle you need to do to hit the other character. But yeah, there's no way to break out of these. Yeah, so that's going to wrap it up for Knox Game Design, December 2022. Hope everyone has a wonderful Christmas and a happy New Year. And yeah, hopefully see everybody back in 2023.